Hello, everyone. Welcome to episode 67 of Reconstructing Cave Story. Today we'll be implementing our sticky collisions. I know I said I was going to do the work on the power Doritos, debugging that, but let's do that in the next episode after we have our sticky collisions all implemented. It'll be a lot easier to keep track of things. So the problem is that quote needs to stick to slopes as he's going down. I'll build and run so you can see the problem right now as it is. So right now he's kind of falling down, and you can really see it because I'm holding down as I'm falling down. So he needs to be sticking to the slopes so that he doesn't keep going back and forth between being on ground and falling, etc. So our solution is, again, the algorithm is from episode 61. I covered a lot of the solutions in episode 61. So if you haven't watched that episode yet, I really highly recommend it. And it's all just these different cases. So if we're on a slope and we're intersecting with a slope tile, then we stay grounded to that slope tile. If we're grounded on a wall and intersecting with a tall slope, then we stay grounded to the tall slope. And then in this final case, I actually had one more case in episode 61, but I was just kidding about that one. Collision order ended up taking care of it, so it's not a big deal. So there's some subproblems, and we need to be able to figure out if we are on grounded on what tile type we are grounded on. So that's our first subproblem, is figuring out what tile type we're grounded on and passing it into our map collidable update method, and then we're going to be getting it from our map collidable on collision method, and then storing it in a player class as a boost optional tile type. And then another subproblem is, when do we do our check? And this check is going to take place in our collision testing after we see if we've actually tested. So let me go into collision map collidable CC, and I'll show you exactly where we're going to be doing this check. So right here we see if maybe position. We're going to be doing our sticky collision check to see right after this. So if we haven't actually collided, then we need to do our sticky check. So we'll do that when it comes to that. So yeah, let's get started. So in order to store in the player class the tile type as a boost optional, we'll need to know what tile type to be storing. So we're going to need to pass that in through our on collision method. So let's look at that in map collidable.h. So we'll want to change all these on collision methods to also take in a const tiles tile type. But instead of doing it inside of a text editor, I'm just going to go into the terminal and do it here using sed. So I'm going to sed find and replace, and then I'm going to look for, and I only want to do this in the declarations. So it's either going to be void followed by space, or it's going to be scoped in using a double colon. And that followed by on collision, and then an opening parenthesis followed by some number of not closing parentheses. And we want to replace that with 1, which will be either the void or the colon, and then 2, the on collision method with all the parameters, and then add in another parameter, which will be const tiles tile type. And then I got to escape the ampersand, because otherwise it sticks in what I captured. Const tile type, escaped ampersand, and then we'll call it tile type. And so this will just go through and insert the argument into all the places that it finds it. So let's do that for cave story source star. And that was a really complicated, do a get diff to. So we see on collision is now taking in a bool direction, const tiles tile type equals 0. And it looks to be doing that for all the declarations. So now we'll need to pass it in. We'll make to see where the first error is, and that's in map collidable.h. That means that we need to, hold on, I can foreground it, load it. We need to include tile types. We'll see the next errors. Yeah, so the next thing we need to take care of is in map collidable, we need to actually pass in the tile type. So let's go to map collidable CC. And we'll look at the error. We need to pass in the tile type here, but we get the tile type from our test collision method, or we only have access to the tile type in our test map collision method or function, actually, in this case. So instead of just returning an optional units of game, I'm going to return a collision info, kind of going back to the way I was doing it before, but that's okay. And it'll be struct collision info, and inside of it we will put our position, so units game position, as well as a tile type. So this will be tiles, tile type, tile type. And so instead of returning an optional units of game, let's return an optional collision info. So let's see what needs to change for this. So instead, we still get a maybe position, so that's right, but we need to return now a collision info. I'll make this const info, and this will be equal to maybe position, as well as the tile type, which we'll get from tiles sub I dot tile type, which is a method that we'll need to create. And we'll return info. So let's go into collision tile dot h and create that tile type method, which will just be a getter. So it'll be tiles const and return tile type. So now we need to change this declaration. These will no longer be optional units of game. They will be collision info. Let's call it maybe position, or maybe info instead of maybe position. And then when we use maybe position, we'll be using maybe info arrow position. And when we pass in our third value, it'll be maybe info tile type. So let's do the same thing down here. Again, it's collision info and maybe info. Maybe info arrow position and maybe info arrow tile type. Now let's build and see if there's another error. We'll definitely see some unused parameter tile types, which is totally fine because we're going to either use them or sort it out later as we go. So it builds and I'm happy. Let's go into our player class and change our on ground. So instead of having on ground, I'm going to use a maybe ground tile. So it'll be a boost optional and it'll need to use tiles type. So let's include those tile type. And let's include boost optional. And we'll change on ground to be maybe ground tile. It'll be boost optional tiles tile type. And let's just do a find and replace of those. In both player.h and player.cc. So this is actually okay, maybe ground tile, returning it as a bool. So boost has, as we've used it before, an overloaded bool cast. So it just checks to see if it exists or not. So this is perfect. So if there is a ground tile, then we will return true for on ground. And if there is no ground tile, they will return false. So now let's go in here and fix up some other stuff. Let's start with our constructor. So we can't initialize maybe ground tile with false anymore. Let's initialize with boost none. instead of setting it to be true, let's set it to be equal to boost make optional. This constructs an optional value, and give it our tile type that we just now started passing into on collision. And then instead of setting it to false, I'm actually going to collapse these states into one. I'm going to set it to be boost none. So now let's build and run and just make sure everything's still working all right, because this was more of a serious change. So yeah, I'm still happy with how things are going. So now let's start working on subproblem 2, which is when do we do our check, and this is going to go in map_collidable.cc right inside of our test map collision after we've checked to see maybe position. So if maybe position doesn't exist, we need to do our check here. But the problem is we're going to need to use our the position that maybe position would have been had it existed. So we're going to need to reorganize this a little bit. Instead of having test collision return in optional units of game, it'll return a units of game along with a boolean whether it collided. So the units of game will be passed no matter what. So let's go into collision tile.h and add that struct in. Let's create a struct test collision info. And it's going to have a bool is colliding, as well as a units of game for position. And this is the position where a collision would have occurred. So no longer is it going to return a boost none if there was no collision. Returns a sets s is colliding is true if there was a collision. And position, we'll do info dot so that we know what we're talking about. Info dot position is the position where a collision occurred or would occur. So let's change this to be a test collision info. And let's go in and actually return it as a test collision info in our implementation. So what does this mean? Let's scope this in. Collision tile. So let's start out at the top of this by creating a test collision info. We'll have some default values. We'll call it info. And the first default is no collision and whatever the leading position is. So that way if it's empty, it'll return a good value for the info.position. So if it is a wall, then we can say info.collision or is colliding equals true. And then instead of returning these values, let's set info.position equal to them. And let's also convert it to a series of else ifs. This way the info position will get set at the bottom and we'll just return, instead of returning partway through each function, we'll just have one return at the end with the info. And so here we're returning the calculated position. Let's instead set info dot, well here we can say info dot is colliding is equal to is colliding. And we can say info dot position is equal to calculated position. And I think that should do it. So all we're doing, again, just as a summary, is now we're returning the position no matter what. Before we were only returning it if there was a collision, but now we're returning the position no matter what, so that we can use the position for our sticky collisions inside of map_collidable.cc. So now there's actually one more piece of information we're going to need before we can do the logic of this, and that is to pass in a ground tile to our test map collision. So we'll call this a boost optional tiles tile type, maybe I'll do it a reference, maybe ground tile, make it const. So when we call test map collision, we'll need to pass in a maybe ground tile, which means our updates are also going to need to take in ground tiles. So we'll do that right now. Const. Update Y is also going to take in a ground tile, but update X won't because we are not concerned with it taking a ground tile. Instead, update X will just pass in boost none. We'll need to update the header so this will compile correctly. Wrong one. Const boost. We'll also need to pass in or include boost optional, but we'll do that in a minute. I see. Pass in boost none here. And for Y, we'll pass in maybe ground tile. And for test map collision for the delta direction, we'll pass in maybe ground tile. But since we don't want to do sticky collisions for the non-delta direction, we'll just pass in boost none. Now that we have all the pieces, we can finally start implementing the logic. So I'm going to do else if, and we only want to do this if our direction is down. So else if direction is bottom side, probably sides, bottom side. And then we'll only do a sticky collision also if we have a maybe ground tile that exists. So those are two of our pre-checks. Now let's look at our algorithm again from episode 61, so I won't go into too much detail about it. But if we're grounded on a slope and we intersect with a slope tile, so if maybe ground tile, and we can use the test method, and we can see if it has tiles slope. So if we are grounded on a slope and we are intersecting with a slope tile, tile sub I is the tile that we're intersecting with, and we can see if dot tile type is a slope tile as well. If it is, then we'll have a collision info, and this optional units of game is no longer an optional units of game, so this should really be a collision tile test collision info. So now it shouldn't be called maybe position, we'll call it test info instead. And we'll check to see if it is colliding, and we'll use its position field, test info dot position. Now back down here, we'll use testinfo.position again, and we'll still use tilesubI.tileType as our info. Now we can build and run. Too few arguments. Okay, so we need to call in player.cc update y. We need to call with our maybe ground tile. And we'll need to do this inside of power Dorito pickup, but we'll just pass in boost to none since we don't have a ground tile. Oops, wrong one. Boost, none. Let's do update X first. Looks like in polarstar.cc we're still using the old way of doing things. Let's go to polarstar.cc and fix that up. So here we are expecting a maybe position from our test collision. Instead, we'll be getting a collision tile test collision info. So instead of maybe position, we'll call it test info, and we'll call test info dot is colliding, and we'll set it to be at test info dot position. Now we should be able to build and run, and I think it'll work out just fine. So yeah, I'm holding down while I'm going down the slope, and it's working out great. You can still see it as I go down from this wall tile down to a slope. There's still he still faces down because he's falling down to the slope, and so that's the next case we need to worry about. But we still have the general case all worked out, it looks like. And I can jump, and he looks just fine. Sweet. So let's go back into map collidable CC and implement the next case. And the next case is if we're grounded on a wall and intersecting with a tall slope. So I'll do else if and I'll test for tiles wall. And then I'm going to test for a tall slope. I'll make a constant to make this easier, so it'll be called tall slope, and we'll just compare it with tilesubI.tileType and see if that's equal to tall slope. Let's go create that constant now. So type slope is equal to tileType. Maybe do it down a line. Dot set tiles slope dot set tiles tall slope. Oops, let's scope these in. So if that's the case, then again we're going to want to return this const collision info. So I'm actually going to collapse this into one state. It was easier to write this way, but it makes more sense to have it as one check. So instead of having that, we'll just make this or this check that we just created. Let's surround this. Are we good now? All right, let's see how this looks. So go to the top slope. I'll be holding down, as you can see, and he just sticks right to the slope, which is brave, which is perfect. It's great. Make sure it works, still works from tall to short. That works. Still fall off. I don't stick to the short slope. So that's good. And this is all making me pretty happy. So I think we can call sticky slopes implemented. So thanks for watching, guys. And in the next episode, we'll work on the power Doritos a little bit more and make sure that those are working out right. So thanks for watching, guys, and happy developing.